So now that we're able to write data to a file and store data in a file, as a next step, I want to make sure we can also extract data from a file and read it from there. And to do that, I'll add another new function, which I'll call getBalanceFromFile. And here I don't need any input because I'm not writing anything to a file. Instead, I just want to write the function like this. And we can now again use the OS package and now the readFile function to read data from a file. And as you see, we'll need to pass in the name of the file that we want to read, which I guess makes sense. And we will get back 2 return values. Now I'll get back to this error thing in one of the next lectures. For now, it's this byte collection, which again is interesting. You might remember it from before. So here I pass the file name, balance.txt, to read file. And since we're now using the same text here, the same file name, of course, in 2 different functions, I'll actually define it as a globally scoped constant. Account balance file could be the name, so that we can refer to this constant instead of repeating the text. I'm doing that even though this constant name which I chose is longer than this value, because now we have one global place where we can edit this value if we ever want to use a different file name. And we therefore don't have to edit this in multiple places in our code if we decide to use a different file name, which makes our code more maintainable and easier to edit. And here I'll bring back that parentheses, which I accidentally deleted. So read file it is that reads the data from that file, and it then returns these 2 values. Now here, I'm only interested in the data, but I still have to create 2 variables if I'm getting back 2 values. So the second value is an error thing, and since we'll get back to this later, for the moment I'll just use an underscore here, which is a special kind of variable name you can use in situations like this when you want to tell Go that you know you're getting a value here, but you don't want to work with it right now. Because otherwise you'll get an error if you have a variable you're not using. With that underscore, Go is fine with you not using it. So with that, we have the data, which is this byte collection. And now I, of course, want to return that data converted to a float. Now again, as often in development, there will be different options. But one simple option is to again use such a balance text helper variable and store data in there, but convert it to a string by wrapping it with the string conversion function. Now float 64 does not work with data. That's why we have to use string, because float 64 doesn't work with such a byte array. String does. And now that we got this balance text, which is of type string, we can convert this to a float. Now, we still can't do that by using the float64 conversion function. This also doesn't work with a string. But we can use another package that's part of the standard library that's called strconf, which stands for string conversion. This package offers some utility functions that help you work with strings. For example, it has a parse float function. And parse float now wants a string as a value. So here we then can pass balance text as a value to parse float. And parse float then actually also wants a second value, a second argument. But here you should simply specify 32 if you want a float 32 value, which is a number value that's less precise than float 64, in which case you would have to specify 64 as a second argument. So here I'll go for 64, which is basically the default float you work with in Go. You would only go for the less precise one if memory management in your application is really important and you want to make sure you're not occupying unnecessary memory, for example. So then this function will again return 2 values, the converted float and another error thing, which I'm also not interested in here. So I'll get my balance and then another error. And since I'm not interested in the error, we can again use this underscore. And therefore now finally, we can also return this balance. So this converted value. For that to work, we just have to let go know about our intentions by defining float64 as a return value type for this function. And with that, we can now call getBalanceFromFile. And the question is, where would we want to call it? And the answer is right when our application starts. Instead of setting the account balance to a hard-coded value like this, I now want to set it to the value I'm getting from my file. So I'll replace this 1000 value here with getBalanceFromFile. And that should be it. Of course, this will only work if you have such a file with such a value. If that file wouldn't exist, you would run into an error. And we'll take a look at that error in the next lectures. For the moment, let's make sure we have a file with such a number inside of it. And therefore, you can save the code like this, and then again run this program. And as you see, it starts here without an error, and I can also take a look at my balance. I can withdraw money and deposit money and exit. And if I do all that, we have the updated balance with the updated value. And that's how we can persist data by writing and reading to files.